So if we work a trig equation where we don't just have a theta, we have like a 3 theta or a 2 theta or 1/2 theta or something like that, then we first set this up using general equations or general formulas and work it out like it was just sine of theta equals 1/2 to start out with. So we just want to think of sine of theta equals 1/2 and the answers that we would get from that equation first. So when I set these up, I do have to know the two places or the two angle measures where when I evaluate at sine I get a positive 1/2. The one in the first quadrant is what? Pi over 6. And then in the second quadrant I say pi minus pi over 6. So that would be 5 pi over 6. So whenever I set up my two general equations, that'll be pi over 6, 5 pi over 6. I say plus 2k pi and plus 2k pi. Now, once we have this set up like we would if we were writing general equations, if that was just theta, I have to, now I don't want theta, I have to write the 3 in front here and here. So 3 theta equals this. 3 theta equals this. Now solve each equation for theta. So to do that, I would have to divide this by 3. If I divide the left side by 3, I have to divide everything on the right side by 3. Now dividing by 3 is the same as multiplying by 1/3. So don't do something crazy here like say 6 divided by 3. That would be wrong. You say pi over 6 times 1/3. 5 pi over 6 times 1/3. Because remember, you flip and multiply. You can think about this like it has a denominator of 1 on the bottom. So my two equations become pi over 18 plus 2k pi over 3 and 5 pi over 18 plus 2k pi over 3. Now, I want all the answers between 0 and 2 pi that would satisfy these two equations. So what I have to do is I have to let k equal different integers and see how many answers I can generate between 0 and 2 pi. Now, I would start out letting k equal maybe -3 or -2 or something like that, so that you start out with getting negative answers. The negative answers, any answer less than 0, we don't want to write down because remember, we just want answers between 0 and 2 pi. But we do need to start out with something that would give us a negative. That way we know that we've started at a small enough k. So I'm going to start at k equals -2. When I work this out, if both my answers are positive, then I'll back up another and start at k equals -3. If they're both negative though, then I'll go ahead and I'll go to -1. And we really don't start getting our actual answers until we start getting angle measures that are greater than 0. And so then we'll work our way up until we eventually get answers that are bigger than 2 pi. And that's when we'll know that we can stop. So for k equals -2, that means plug in a -2 into each formula. I'm going to get theta equals pi over 18. That's going to be minus 4 pi over 3. So I'm plugging in a -2 there. Do the same thing in the next equation. That's 5 pi over 18 minus 4 pi over 3. Now, I can tell just by looking that these answers would be negative, but I'm going to go ahead and get common denominators and show you. So the common denominator would be 18. So this is pi over 18 minus 3 are going to 18 6 times. 6 times 4, that's going to be 24 pi over 18. And so if I subtract that, I get a negative 23 pi over 18. So that's less than 0. That's not one of my answers. Do the same thing on the next one, the next equation. Get 5 pi over 18 minus 24 pi over 18. So that's going to be a negative 19 pi over 18. Alright, so neither one of those answers are greater than 0. They're both less than 0, so I'm not going to take those answers. So now I'm going to move up to k equals negative 1. So plug in a negative 1 in for k, and I'll have pi over 18 minus 2 pi over 3 and pi over 5 pi over 18 minus 2 pi over 3. Let's see if either one of these answers are greater than 0. So again, the common denominator would be 18. So this is pi over 18 minus 3 going to 18 6 times. 6 times 2 is 12 pi over 18. So 1 pi over 18 minus 12 pi over 18, that's going to be a negative 11 pi over 18. Of course, that's less than 0 because it's negative, so that's not one of my solutions. This one here should probably be a little closer. Let's see. 5 pi over 18 minus, again, that's 12 pi over 18, so negative 7 pi over 18. That's still negative, though, so we don't take that answer. Now, it just so happened that plugging in negative values for k ended up not giving me an answer that I could use, but I still need to check and make sure. Alright, so now I increase k by 1, I go to k equals 0. This is the easy one, because when k is 0, this stuff that I'm adding just goes away. So when k is 0, I'm going to have theta equals pi over 18 and theta equals 5 pi over 18. These are for sure two of my answers, because those are greater than 0 and less than 2 pi. Alright, so now go to k equals 1. Increase k by 1. Plug in a 1 for k, and I'm going to have pi over 18 plus 2 pi over 3 and 5 pi over 18 plus 2 pi over 3. Alright, again, get common denominators, so it's going to be pi over 18 plus 12 pi over 18. Right, 2 pi over 3 is 12 pi over 18. So now that's going to be 13 pi over 18. So that's a solution. That's between 0 and 2 pi. And the next problem, that's going to be 5 pi over 18 plus 12 pi over 18. That's 17 pi over 18. Now, 17 over 18 is still less than 1, so that's less than 1 pi. So those two are definitely solutions. Now let k equal 2. Alright, so I'm going to have pi over 18 plus, if k is 2, that's going to be plus 4 pi over 3. Alright, so get a common denominator. That's going to be pi over 18 plus 3 goes into 18, 6 times 4 is 24 pi. So that's going to be 25 pi over 18. Now 25 over 18 is larger than 1, but it's not larger than 2. Our cutoff is 2 pi. So as long as the fraction part is less than 2, then we keep going. Alright, so the other formula was 5 pi over 18. So it's 5 pi over 18 plus 4 pi over 3. Or 5 pi over 18 plus 24 pi over 18. That's going to be 29 pi over 18. Now 25 pi over 18 and 29 pi over 18 are both less than 2 pi. So that's 2 more solutions. So far we have 6 solutions. I bet this is where things are going to get too big. Let's see. K equals 3. So if K is equal to 3 up here, then that would be 6 pi over 3 or plus 2 pi. But when you're starting with an angle measure that's positive and you add 2 pi to it, that's going to be bigger than 2 pi. I will add the numbers together just for fun, but adding 2 pi to a positive angle measure makes it bigger than 2 pi. So again, common angle, you got to get a common denominator, so that's going to be pi over 18 plus 36 pi over 18. That's going to be 37 pi over 18. That's bigger than 2 pi. And of course, the angle measure that's larger is going to be even larger. So that's going to be 5 pi over 18 plus 36 pi over 18, which is going to be 41 pi over 18. Of course, that's bigger than 2 pi as well. So we stop there. We don't take those answers. Our solution is going to be pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and lastly 29 pi over 18. The larger the number in front of the theta, go back and look at our original problem, the larger the number in front of the theta, the more answers you're going to have. The smaller the number in front of the theta, the less answers that you would have when you compare them to just, say, sine of theta equals 1/2. So if there's a 4 in front, there'll be even more answers. 5 in front, there'll be more answers. Usually you don't worry about thetas that are or numbers in front of theta that are bigger than, say, 2 or 3 or 4, because it would take too long really to work out the problem. But you could if you wanted to. Alright, tangent of 2 theta equals -1. So we want theta to be greater than or equal to 0, less than 2 pi. We want to get all the answers between 0 and 2 pi, basically, including 0. So what we need to do is we need to first figure out what 2 quadrants can I get answers from. Since this is tangent, if I want a negative, then I want the answer from the 4th quadrant and from the 2nd quadrant. Alright, to do that, use a reference angle chart, say pi minus the reference angle, 2 pi minus the reference angle. So what you have to figure out is the tangent of what would give you a -1. Well, actually the tangent of what would give you a +1. So that would be pi over 4. And then use that and the reference angle chart, say pi minus pi over 4 and 2 pi minus pi over 4. This will give you the multiples in the 2nd quadrant and 4th quadrant that you need. So that's 3 pi over 4 and that's 7 pi over 4. So when I set up my general equations or my general formulas, first I just want to say theta equals 3 pi over 4 plus Now, how often does tangent repeat? Every pi. So put plus k pi. And also I'll put 7 pi over 4 plus k pi. So we start the problem off like that, regardless of what's in front of the theta. Well, this was 2 theta. So now what we have to do is come down to our general formulas and put a 2 in front of each theta. And now solve for theta in each equation. So divide everything by 2. Remember, dividing by 2 is the same thing as multiplying by 1/2. So my equations become, or my formulas become, theta equals 3 pi over 8 plus k pi over 2. And theta equals 7 pi over 8 plus k pi over 2. Now, I want to make sure that I start with a small enough k so that I can get some negative answers to start off with, but I'm not going to include those negative answers in my solutions. But it's important that at least one of them comes out to be negative. Let's start out with just k equals -1 and see if that's far enough down on the negative integer list. I think it will be. We'll see. If not, we can go to k equals -2. So for k equals -1, I'm going to have 3 pi over 8. Now if I plug in a -1, that means that's just going to become minus pi over 2. And 7 pi over 8 minus pi over 2. Again, we're plugging the -1 in for k, so that's going to make this last term that I add a -1 pi over 2, or just negative pi over 2. Now get a common denominator, so I have 3 pi over 8 minus, it's going to be an eighth. 2 will go into 8 4 times pi is 4 pi. So 3 pi over 8 minus 4 pi over 8 is -1 pi over 8. So that answer is less than 0, so that angle measure will not be included in our solution set. Alright, let's do the same thing on the next formula here. I'm subtracting 4 pi over 8. So 7 pi over 8 minus 4 pi over 8 is 3 pi over 8. That is greater than 0. So we're not including the negative, but we do include the answer that's greater than 0, less than 2 pi. So that's one of our solutions. Alright, now increase the value of k by 1. That would make it k equals 0. So if k equals 0, this is the easy case, because what you're adding here and here just goes away. And that will give me theta equals 3 pi over 8. Theta equals 7 pi over 8. Well, you already got 3 pi over 8, so of course you don't write that answer down twice. It's the same answer. But we do have a new answer here, 7 pi over 8. Now let k equal 1. So if I plug in a 1, I'm going to have theta equals 3 pi over 8 plus, if I plug in a 1, I'll have pi over 2. And theta equals 7 pi over 8 plus pi over 2. Alright, so get a common denominator. It's still going to be 4 pi over 8, so this time it's going to be plus 4 pi over 8. So 3 pi over 8 plus 4 pi over 8 is 7 pi over 8. Same answer we got before here. And 7 pi over 8 plus, again, 4 pi over 8. That's going to be 11 pi over 8. Now, 11 over 8, that is greater than 1. So that's bigger than 1 pi, but that's not bigger than 2 pi. So I do need to keep going until I get answers that are bigger than 2 pi. But this 11 pi over 8 is part of my solution set. It's one of my solutions. All right. Now let's let k equal 2. So if k is equal to 2, we're going to have theta equals 3 pi over 8 plus, I'll plug in a 2, it's going to be plus pi, and 7 pi over 8 plus pi. Now, getting the common denominator for pi is pretty easy. You just make it 8 pi over 8. And so 11 pi over 8, that answer is repeated. And then 7 pi over 8 plus 8 pi over 8, that's 15 pi over 8. 15 divided by 8, that's almost 2, but not quite. Alright, that's a little bit less than 2 pi. So what that means, I can almost guarantee this is going to be too large when we let k equal 3. When k equals 3, I have 3 pi over 8 plus 3 pi over 2 and 7 pi over 8 plus 3 pi over 2. Maybe saying, where are you getting that 3 pi over 2? From our formulas up here, if I plug in a 3, that becomes 3 pi over 2. 3 pi over 2. Alright. 3 pi over 8 plus 3 pi over 2. It's going to be 3 pi over 8 plus, common denominator is 8. 2 goes into 8 4 times. 4 times 3 pi is 12 pi. So that's 15 pi over 8. That's a repeated answer that we just got. But look at this one here. I bet this one's going to be too big. 7 pi over 8 plus, again, 12 pi over 8. So that's going to be 19 pi over 8. 19 divided by 8 is bigger than 2. So that's bigger than 2 pi. So this is where we start getting too big. So we have 4 answers. The solution set is 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8.